How do I troubleshoot analog filter issues in real circuits? Imagine you have a circuit that should filter out high frequencies but instead lets through noise or distortion. Troubleshooting these issues can seem tricky, but with a clear approach, you can pinpoint the problem quickly. First, check the filter's expected response. Use a signal generator to send a known test signal into the input. Then, measure the output with an oscilloscope or spectrum analyzer. Compare what you see with the theoretical response for your filter type, whether it is low pass, high pass, band pass, or band stop. If the output doesn't match the expected response, move on to the next step. Verify the component values. Resistors, capacitors, and inductors must match the design specifications. Even small deviations can shift the cutoff frequency or distort the shape of the filter's response. Use a multimeter to check resistor values and a capacitance meter for capacitors. Pay special attention to capacitors because they can vary a lot due to tolerances. If you find any components outside their specified range, replace them and retest. Next, look for damaged or faulty parts. Physically inspect the circuit for signs of damage. Swollen or leaking capacitors, burnt resistors, or cracked inductors are common issues. Replace any suspect components and test again. Aging capacitors can lose their capacitance or develop leakage, which affects the filter's behavior. Check the power supply and biasing. Many analog filters, especially active ones using operational amplifiers, need stable power supplies. Measure the supply voltages with a multimeter or oscilloscope. Make sure the voltages are correct and free from excessive noise or ripple. If the power is unstable, the filter's performance will suffer. Look for parasitic effects. Real circuits have unintended capacitance and inductance from PCB traces and component leads. These parasitic elements can alter the filter's response, especially at higher frequencies. Keep the PCB traces short and avoid running sensitive filter lines near noisy signals or power lines. Ensure proper grounding and shielding. Poor grounding can introduce noise or cause instability. Confirm that the circuit has a solid ground plane and all ground connections are secure. Shield sensitive parts if external interference is a problem. Test for oscillations or instability. Active filters can oscillate if the feedback network is not correct or if component values are off. Use an oscilloscope to look for unexpected oscillations at the output. If you see oscillations, check the feedback components and make sure they match the design. Finally, measure the input and output signals. Confirm the input is within the filter's specified range. Overdriving can cause distortion or nonlinear behavior. Also, check that the next stage isn't loading the filter, which can change its response. Use known good signals and connections to isolate the problem. Environmental factors like temperature and humidity can also affect component values. If the filter works in one environment but not another, consider these external influences. In summary, troubleshooting an analog filter involves verifying component values, checking power supplies, ensuring proper grounding, and looking for parasitic effects. Use test equipment to compare actual responses with expected ones. Addressing these areas systematically will help you find and fix most issues in real circuits.